Good morning or good afternoon, everybody. So I'm really happy to introduce the Grablink Duo board. So during this presentation, I will not only present the main feature of this board, but I will also highlight the differences with the previous generation of Grablink frame grabbers. So the Grablink Duo is a camera link compliant frame grabber. You can use it with two camera in base configuration or one camera in base, medium, full 72 or 80-bit configuration. So it means that this board alone can replace a Grablink dual base and a Grablink full. The Grablink Duo is also PoCL compliant, which is an advantage compared to the Grablink full, for instance. It implements the ECCO technology, which means that you can use longer cable compared to what the camera link norm specifies. The board is equipped with a PCIe Gen 2 4-link bus for a sustainable bandwidth of 1.7 gigabyte per second. We will see that there are 20 GPIOs available on this board, directly on board. And also a very important point is that the Grablink Duo is compatible with the eGrabber driver, and it also fully supports our Memento event logging tool. So as I have mentioned, this board, the Grablink Duo, is able to connect one or two camera and to switch from one configuration to another. We provide different firmware variants. We have a one camera firmware variant for one area scan camera, whatever the camera link configuration. We have a two camera firmware variant for one or two area scan camera in base configuration. And as you can see, we also provide a firmware variant dedicated to line scan camera. One camera line scan, two camera line scan. Of course, to manage those firmware variants, to install a new firmware variant or to upgrade an existing firmware variant, we provide a Grablink firmware manager. So as you can see, this is exactly the same look and feel as the CoaxLink firmware manager. To configure a camera connected to a Grablink Duo board, you can use the standard serial communication, which means that the application software can use the Camera Link API functions to control the camera. Since this board is fully compliant with the Camera Link standard, we also provide a dedicated DLL to manage the serial communication. Now, what is new compared to the previous generation of Grablink frame grabber is that the Grablink Duo is Gen CP compliant. So Gen CP is a communication protocol which allows to retrieve the XML file of a device, in this case a camera, and perform read or write operation to change the value of a camera parameter, for instance. The board also implements the ECCO technology. So ECCO stands for Extended Camera Link Cable Operation. So as you know, in this world, nothing is perfect. So when you use a camera link cable, the propagation delay between different lanes of the cable is not the same. And the difference is called the skew. The ECCO technology allows to compensate for the skew, and this compensation is done dynamically, so on the fly. So using ECCO, you can operate with cables that are 30% longer, or you can achieve 30% higher speed for your camera. Based on the test we have made with the Grablink Duo board, we know that you can reliably use cable up to 10 meters. And maybe now the most important point of this presentation is the driver. So unlike the previous generation of Grablink frame grabbers that relies on the multicam driver, this is not the case for the Grablink Duo. The Grablink Duo uses the eGrabber driver. So this is exactly the same driver as the one we are using for the CoaxLink series. It means that if you want to upgrade an existing multicam-based application to support the Grablink Duo, it will require code modification. And of course, we want to make this migration as easy as possible for the end user. So we provide a migration guide. It's called the eGrabber for multicam users. This migration guide is already available online. You can also download a PDF version of this file. Actually, it is part of the eGrabber Programmer's Guide. We will, of course, provide sample program explaining and showing how to use the Grablink Duo board with the eGrabber driver. Using the eGrabber driver for this new board is really an advantage. First, because the eGrabber driver is a modern driver, but the fact that the board will directly use this eGrabber driver means that natively it will be possible to use the eGrabber recorder. So it makes it very, very easy to record a sequence of images that have been acquired with the Grablink Duo. And from a general point of view, it means also that you can use exactly the same API to control the acquisition of a co-express camera, a CameraLink camera, and a GigaVision camera, so which is a great advantage. Of course, the eGrabber Studio will also support the Grablink Duo board. As you know, with multicam, if you want to configure a frame grabber according to the operating mode of the camera, you have to load a cam file. So a cam file is just a list of assignment function for multicam parameters. When you are using eGrabber, the cam file are replaced by Gen API scripts. These are the same script as the one we are already using with the QuaxLink series. The syntax of the script is pretty similar to what we have with JavaScript. So it means that you can define functions, which is not available with the cam file. And the script not only configure the device, so the frame grabber, but also the camera and all the I/O tools that are related to the triggering, which is not the case for cam file that can only configure the device. In terms of operating system, the eGrabber driver, of course, supports Windows for 64-bit platforms, Linux, again, 64-bit platform, and Mac OS as well. Concerning the onboard preprocessing, on the Grablink Duo board, we have a frame store of 512 megabytes, which is, by the way, 8 times more memory than what we have to store image data for a Grablink full. Data conditioning is also available for 10, 12, 14, up to 16 bits. It is possible to retrieve statistics about what's happening in the data stream. So for the area scan firmware variant, the 1 camera and 2 camera, you can retrieve the frame rates. For all the other firmware variants, you can retrieve the line rates and the data rate. And this interval for the averaging, let's say, is freely configurable. The board has also lookup tables for monochrome images, 8-bit, 10, 12, 14, and 16-bit pixels. We have also lookup tables for color images, for RGB. We have implemented a Bayer CFA to RGB decoder in the FPGA of the Grablink Duo. And please notice that in terms of speed, we doubled the speed compared to the Bayer decoder we have on the Grablink Full, for instance. So really, this Grablink Duo is really an improvement compared to the previous generation of Grablink frame grabbers. This list of pre-processing function is not exhaustive, and on demand we can add some more functionalities. Now, a very interesting topic is the GPIOs. So we have on board 20 digital I/O lines. Those 20 lines can be freely allocated to any camera. Again, this is an advantage compared to the Grablink Dual base, because in this case, each camera has to manage its own set of dedicated I/O lines. This is not the case with the Grablink Duo. You can freely allocate the I/O lines to any camera. And again, compared to the Grablink Full, for instance, we have twice as many I/O lines available. So in green, you can see that the internal I/O connector are highlighted. So for each connector, we have 10 I/O lines. We also have an additional I/O connector directly on the bracket, the external I/O connector, which exposes exactly the same I/O line as the one on the internal I/O connector, which is next to it. If you want to expose on the bracket the I/O lines that are available on the second internal I/O connector, you can use the I/O adapter cable. This is exactly the same module and adapter that we are using for our coax-link series frame grabbers. The 20 digital I/O lines can be subdivided in 4 types. We have 8 isolated current sense inputs that support voltage up to 30 volts and a signaling up to 200 kilohertz, which is again an advantage compared to the previous generation of Grablink board, because in this case the signaling is limited to 50 kilohertz. We have individual galvanic isolation. For the support of quadrature motion encoder, we provide 4 high-speed differential inputs that support a signaling up to 5 megahertz. We also have on this board isolated current output up to 30 volts again, and a signaling up to 100 kilohertz. And finally, and again, this is an improvement compared to the previous generation of Grablink frame grabbers, we have TTL I/O lines that are available on the board with a signaling up to 5 megahertz as well. And on each of the connector, we have plus 12 volt power output available. So as mentioned, the 20 I/O lines are available directly on board. It is possible to use additional I/O lines by using an extension module, and this extension module has to be connected to the I/O extension connectors. So the I/O extension module that we have is the TTL RS422. Which feature up to 20 TTL I/O lines or 10 RS422 I/O lines. So in case of TTL, the signaling is up to 1 megahertz, and for the RS422, it's the ultra-fast signaling up to 10 megahertz. The output of the TTL is a low voltage TTL, so 3.3 volts output level. We have another module which is, let's say, almost the same, except that the TTL output is CMOS 5 volt. But concerning the number of I/O lines for TTL and RS422, this is exactly the same thing, and this is also the same configuration concerning the signaling. By the way, we have also a third module which feature 24 TTL I/O lines. Now the next topic is C2C link. So as you know, if you know already our coax-link series, the C2C link allows to very accurately synchronize the acquisition between several cameras, area scan or line scan. One of the boards is defined as the master. The master board receives all the triggering information from a motion encoder, from a present detector, for instance. So all the triggering is managed by the master board, and the master board will just propagate those triggering information to all the slaves. So the connection between the master and the slave is made through the C2C link connector. The triggering is up to 2.5 megahertz. C2C link is already available for the previous version of the Grablink frame grabbers, but it is only available for line scan camera, not for area scan camera, and the triggering rate is up to 80 kilohertz only. So thanks to C2C link, it is possible to synchronize cameras that are connected to the same Grablink Duo board in case of a 2-camera or 2-camera line scan variant. It's also possible to synchronize cameras that are connected to different cards in the same PC. So remember that you defined one of the board as the master and the other as slaves. And to connect all of them, you have to use an accessory, which is C2C link ribbon cable. If you want to synchronize cameras that are connected to different boards plugged in different PCs, then in this case, you have to use the inter-PC C2C link adapter, which is the one we see on top here. So just for a closer look of this adapter, the inter-PC C2C link adapter, it features, of course, a C2C link connector here, which allows to connect all the boards in one PC to this inter-PC C2C link adapter. We have here two RG45 connector, one in, one out. So it allows to daisy chain the different inter-PC C2C link connector for several PCs, up to 32 PCs, actually. And since we have some room available on the bracket, we have also added an external I/O connector that exposes the I/O connection that are available on the internal I/O connector of the Grablink Duo board. So in this configuration, we have two PCs, we have 3 Grablink Duo board, and we have 4 cameras. C2C link allows to synchronize the camera that are connected to the 2 Grablink Duo board in the same PC. In this case, you just have to connect the master board and the slave board with a C2C link flat cable. And to synchronize cameras that are connected to boards that are plugged in different PCs, you have to use the inter-PC C2C link adapter. And of course, you have to connect these two adapters using a standard Ethernet cable. So in this configuration, we have 4 cameras that can be synchronized. And you just have to provide all the triggering information to the master board. The master board, thanks to the C2C link flat cable and to the inter-PC C2C link adapter, will just propagate all the triggering information to all the slaves in the system. And then all 4 cameras are synchronized. Let's switch to the I/O toolbox. So the I/O toolbox is a configurable interconnection of tools that generate events. Typically, they generate triggers. Among those tools, we have the line input tool, which is an edge detector. It can be assigned to any input lines. We have up to 8 line input tools available on the Grablink Duo board. And this tool will generate events on the rising or the falling edge of the signal of the triggers. Then we have the user action scheduler tool, which allows to execute dedicated user action at scheduled time or based on the position of the motion encoder. So among the user action, we can set the value of any bit of the user output register, meaning that you can change the state of any output line, and also the generation of any user events. User events, typically, they are used to trigger the acquisition of a new frame or a new page. And then the third tool is the quadrature decoder tool. Typically, this tool is used in combination with motion encoder, and it consists of several tools. The first one is the decoder edge detector, which delivers events on the transition of a selected pair of input lines. We have also a backward motion compensator, which is able to pause the line acquisition when a backward movement is detected, and then resume the line acquisition at the exact same position where the backward motion was detected. And finally, we have also a 32-bit up-down counter to deliver the position of the encoder. So those 3 tools are the line input tools. and they generate events, and those events can be managed later on by these three tools. So the delay tool, which is able to delay the event by a programmable time or a certain number of motion encoder tick, specifically in case of a lens scan application. We also have the divider tool, which is able to divide the incoming event signal by an integer value. And finally, the multiplier and divider tool, which is what we used to call in multicam the rate converter, will multiply or divide the incoming event signal by a non-integer integer value. So this gives a lot of freedom in the setup of a lens scan application, because whatever the encoder, the motion encoder that you will use, whatever the resolution of this motion encoder, you can still achieve square pixels. So this is very, very important tool. Finally, Memento. So you know that Memento is our very accurate event logging tool. You can log events that are related to the operation of the camera, of the frame grabber, the driver, in this case the eGrabber driver, of course, and also the host application. So in the application, you can also populate the messages into Memento. Memento also offers a graphical representation of timestamp event very, very accurately, and provide context information about those events. As you know, Memento is very, very useful to set up the system, to do debugging or profiling of the application. So the Memento is already supported by the previous generation of the Grablink board, but in this case, it's restricted to only specific kinds of Memento. For instance, it's not possible to retrieve information about what's happening in the FPGA. You cannot retrieve information about DMA transfer or about the camera readout, for instance, or the triggering. So those information, they are not available in Memento for the previous generation of the Grablink series. In case of the Grablink Duo, in particular, we have the support of the analyzer plot, which means that we can have a graphical representation of any transition of signal, like, for instance, the camera readout. We know when the camera readout is starting and when it's completed. We have also information about the DMA transfer to the host PC memory. Information about the management of the GNTL buffer queue, as well as some event counter, for instance. So we really have a full support of Memento in this case. So now I think it's time to switch to the demonstration. So let's move on. So I connect to my remote PC. So you have recognized our eGrabber Studio application. As you can see here, eGrabber Studio has detected the presence of a Grablink Duo board in the PC. This one has one camera firmware, so it's for area scan camera, and we have here the serial number of this board. So I just select stream, I open it. Okay, so if I just go and browse the parameter, I have here the remote device, which is of course the camera. So it's a camera link camera. We have here a measurement of the pixel clock of the camera. We have the image size, the width and the height, the pixel format. Here we have 8-bit per pixel. We have the tab geometry. So you can see we support several tab geometry here. So remember what I have mentioned in the introduction. So in case of multicam based frame grabber, we are using CamFile to configure the frame grabber according to the operating mode of the camera. In case of the Grablink Duo, since it relies on eGrabber, the eGrabber driver, we will use a script. So I can load a script. Okay. And then I run this script. So I will just execute the functions and the assignment of the feature value. So if I go back here now, as you can see, the tab geometry has changed. And if I display the device, I can see that the camera control method is RG, meaning that the Grablink Duo will control the frame rate and also the duration of the exposure. In this case, we are not using C2C link. So I just have one board in the PC. We will overlap the exposure and the readout. This is the minimum time between two triggers. The value is expressed in microseconds. The cycle minimum period specify the time between the two triggers. Here we have 10,000 microseconds, which correspond to 100 frames per second. This is the exposure duration, so 5 milliseconds. I have also here defined strobe. So the strobe duration is 3 milliseconds, and there is a delay of 1 millisecond between the start of the exposure and the start of the strobe signal. Cycle trigger source is set to immediate, meaning that if I click the button, I get immediately the acquisition. So here, you have the picture here of a Grablink Duo board. I think it's a bit saturated, so I will just reduce a little bit the exposure here. So let's put it to 4,000. Okay. So in this case, the acquisition starts immediately because the trigger source is immediate. But as you know, we can use triggering. So I have connected to one of the input line of the Grablink Duo a pulse generator. So let's stop the acquisition. I go to the interface. In the interface, I have access to the I/O toolbox. I will select the first line input tool, and I will use as source the input line on which I have connected the pulse generator, which is this one. So it's the first isolated current sense input on the first connector. Okay, and if I go back here, and instead of using immediate, I select line 1. Then I can start the acquisition. I can get information about the frame rate. So I have set, well, it's not really obvious here on the oscilloscope, but I have set a frequency of 50 Hertz, and we get 50 frames per second. Here you have information about the line rate and the data rate, as well as the number of images that has been acquired so far. Okay. So I can also show you that I don't have to use directly the signal that comes to the which is connected to this input line. I can also use a divider tool. So I just select my divider tool. As source, I will of course select the line input tool number 1. I will enable this, and in this case the division factor is 2, which is okay. I can keep this value. And here, as trigger source, I select my divider tool. Okay, so let's come here. So I have 50 Hertz as input divided by 2, so I get 25 frames per second. So as you can see, it's pretty easy to combine the I/O tool from the I/O toolbox and to select them to do the triggering. So as you know now, this board is fully compliant with Memento. So let's start Memento. Okay. So I have my activity plot here, the message plot here. As you can see, I have the message window, so we have all the messages here. So let me just pause, and I want to show you the analyzer plot I have mentioned during the presentation. So show analyzer, and I will analyze all the traces that have been produced. So So here we have a graphical representation of, let's say, waveforms for several features, like the DMA transfer. So here in purple we have the DMA transfer. We have the triggering, which appears in blue science. In red we have the strobe, and in orange we have the camera readout. So let's zoom a little bit. Okay. So as we can see, if I just reach this point here, I will just set this as my time reference. Okay. So remember that I have an exposure duration of 4 milliseconds, which can be measured here. After 1 millisecond, I have the rising edge of the strobe, which is here. The strobe duration is 3 milliseconds as well, and the duration of the exposure is also 4 milliseconds. So we have the trigger falling edge and the strobe falling edge as well. And then we can see that 53 milliseconds microsecond later, excuse me, we have the start of the camera readout, which is something I can also measure here. So if I just zoom in and I just go to the end, where it is, okay, it's here. If I just take the time difference between, excuse me, I'm just frozen a little bit. So if I want to measure the time between the start of the readout of the camera readout and the end of the trigger, which is here, we have the 53 milliseconds. I can also have the difference between the start of the camera readout and the start of the DMA transfer, which is also available here. So I have 2 microseconds later. Then I have my camera readout, which is completed here. And then I can retrieve information about the DMA transfer, information about the metadata, so the image size, for instance, the pixel formats, and all kind of information that are available directly in the metadata of the image that has been acquired. And at this point, the software, so the application, is informed about the availability of the image. So as you can see with the Grablink Duo board, I have a full support of Memento.